Push a heavy box across the floor. At first, it refuses to budge, resisting harder the harder you push. Then, all at once, it breaks free and slides. That single everyday moment hides two different kinds of friction, governed by two different laws. This video reveals both and the tipping point between them. When surfaces touch, they resist sliding across each other. Drag a block over a table, or let it sit on a ramp, and either way, a sideways force acts along the contact surface. This is dry friction, and it comes in two distinct forms. When the two surfaces are moving relative to each other, the resistance is kinetic friction, also called sliding friction. When the surfaces are not moving relative to each other, yet a sideways force still holds, like a block resting motionless on an incline, that is static friction. Leonardo da Vinci first measured kinetic friction over a 20-year span ending around 1515. He found something clean. The magnitude of kinetic friction is proportional to the normal force pressing the two surfaces together. Written as a law, F sub k equals mu sub k times n. Here n is the normal force, and the mu sub k is the coefficient of kinetic friction, a pure number with no units that captures how rough the pairing of the two surfaces is. His second finding is the surprising one. The friction does not depend on the contact area. Take two blocks of the same mass but different footprints. Lay one flat, so it touches over a wide area. Stand the other on end, so it touches over a much smaller area. Push each so it moves at constant speed. The force you need is identical. Twice the contact area and the friction is the same. What matters is how hard the surfaces press together, not how much of them touches. Da Vinci never published. His results were rediscovered by Guillaume Amontons and printed in 1699. Later, Charles-Augustin Coulomb added a third property. For ordinary sliding speeds, kinetic friction does not depend on how fast the object moves. To keep the bookkeeping clear, we label the kinetic friction on surface 2 as it slides over surface 1 with the ordered subscript 1, 2. Its direction is always opposite to the motion of surface 2 relative to surface 1. Friction fights the sliding. Now the second kind, static friction, the force between two surfaces held at rest against each other. It forms a Newton's third law pair. Press your hand flat on a table and push sideways gently at first. Nothing slides. Push harder and still nothing. But you can feel the resistance climbing to match you. Push harder still and suddenly your hand breaks loose and skates forward. That resistance before the break is static friction. With no sideways push, it is zero. As you push, it grows to exactly cancel your push, keeping your hand still, right up until the instant it can hold no longer and the hand slips. So static friction is not one fixed value. It adjusts, ranging from 0 up to a maximum reached the moment sliding begins. 0 is less than or equal to F sub s, which is less than or equal to the maximum static friction. That maximum follows the same shape as the kinetic law. It is proportional to the normal force. The maximum static friction equals mu sub s times n, where mu sub s is the coefficient of static friction. And crucially, mu sub s is slightly larger than mu sub k. That small gap is the stick, then slip, the catch of chalk on a blackboard or a bow drawn across a violin string. Static friction also points wherever it must to oppose you. Push the block left and the static friction points right. Push it right and the static friction flips to point left, always directly against the applied force as long as nothing accelerates. This exposes two differences from sliding friction. First, static friction changes its size and its direction to match the applied force, while kinetic friction stays fixed. Second, static friction has a ceiling. Push along the surface harder than the maximum static friction, and the object can no longer hold. It breaks loose and switches to kinetic friction. That threshold is the just slipping condition. Two laws then. Kinetic friction is fixed at F sub k equals mu sub k times n blind to contact area and to speed. Static friction is a range from 0 up to its maximum, mu sub s times n, always opposing whatever pushes on it. Because the static coefficient exceeds the kinetic one, objects cling, then break free. Cross the just slipping threshold and the sticking gives way to sliding. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.